In this video, we'll see how to solve compound inequalities. This is an example of a compound inequality joined by and. We're trying to find the value of m that will make both statements true. So negative 3 is less than or equal to 4m minus 5. And 4m minus 5 is less than negative 1. Well, what I think about is if this was an inequality and I didn't have this part, what would I do? I would add 5 to start isolating the variable. Well, that's exactly what we're going to do here, except we are going to add 5 to all parts of this compound inequality. So I'm going to add 5 to the expression, and then I'm going to add 5 to both sides. And this is how I start solving it. Negative 3 plus 5 is 2. That's less than or equal to 4m, which is less than 4. I'm going to divide both sides now by 4. Well, 2 divided by 4, that's just 1/2, less than or equal to m, which is less than 1. That's my compound inequality. M can be anywhere from 1/2, including 1/2, all the way to 1. So if I graph this, I'm going to label those two boundaries, 1/2 and 1. I need a closed circle on 1/2. I need an open circle on 1, and m could be anything in between here. So you could substitute something like 3/4 for m, and that would be between negative 3 and negative 1. Now, what is interval notation? Interval notation is a way to show this number line. Since it can be 1/2, I'll put a bracket there because it could be at 1/2 and mark my boundary. And then this interval is going to go all the way to 1, but it can't be 1, so I use a parenthesis. Let's take a look at this next one. I've got negative 7 is less than or equal to m over 2 minus 3, which is less than 3. I am going to add this 3 to all sides of this. So negative 7 plus 3 is negative 4, less than or equal to m over 2, which is less than 6. And now how do I isolate m? I have to multiply m over 2 times 2 to get m by itself. So let me multiply 2 everywhere. I get negative 8 less than or equal to m, which is less than 12. So for this inequality to be true, m can be from negative 8 all the way to 12. And according to the signs, we can include negative 8, but not 12. And it's everything in between there. And what would the interval be? Well, since it can be negative 8, I'll put a bracket there, and then comma, and it's going to go all the way and ending at 12, but it can't be 12, so I put parentheses there. All right, now this is an inequality joined by or. So the solution to this inequality makes either of these two statements true. 2x plus 7 is less than 1, or negative 4x plus 3 is less than or equal to negative 5. Well, I want to basically then solve each inequality separately. So how do I get x by itself in this first one? Well, first I'll subtract 7. 2x is less than negative 6. Then I'll divide by 2. X is less than negative 3. That's one part of this, but I want to solve for the other part too. I'm going to subtract 3. Negative 4x is less than or equal to negative 8. Divide both sides by negative 4. And we're going to get x. And then remember to flip the sign, because I divided both sides by the negative there, is greater than or equal to 2. So this is my solution to this compound inequality. x is less than negative 3, or x is greater than or equal to 2. And now I want to graph this. Here's negative 3. Here's 2. I have an open circle on negative 3. And everything goes to the left because x is less than negative 3. I fill in my circle at 2 because x could be 2, and x could be anything bigger than 2, so I go to the right. And now, what's my interval? Well, what is over here all the way on the left? That's negative infinity. That's not an actual point, so we put a parenthesis there. And then negative 3 is where this part of my inequality ends. And again, it can't be negative 3, so I put a parenthesis there. Or, now let's look at this other inequality. It starts here at 2, but it can be 2, so I use a bracket to show it could be 2, it could be equal to 2. Or, what is this part all the way over here? That is positive infinity. And we close that with a parenthesis. Okay, last one here. I am going to subtract 3 on all sides of this compound inequality because I'm trying to get d all by itself. So 3d is less than or equal to negative 4. Divide both sides by 3. D is less than or equal to negative 4/3. Or, and now how do I solve the second part of this? I'm going to subtract 2. 5d is greater than or equal to 10. Isolate d by dividing both sides by 5. d is greater than or equal to 2. I want to graph this inequality. Remember, there's 2 parts to it. Each part is part of my solution here. So d is less than or equal to negative 4/3. It's greater than or equal to 2. Well, it could be negative 4/3, so I fill in the circle. Or it could be anything less than that, so I go to the left. It could be 2. It's greater than or equal to 2, so I fill in the circle. Or anything to the right of that because it's greater. And finally, what's my interval? Well, all the way to the left, that's negative infinity. And then it ends here at negative 4/3. Parentheses for negative infinity. And a bracket because it could be negative 4/3. Or a bracket because it could be 2. And that goes all the way to infinity. We close it with a parenthesis. So what we're saying is if x is somewhere, or sorry, d is somewhere over here, well, that's going to make this inequality true. So it's a solution to this compound inequality. But if d is something over here, like 5, that makes this inequality true. And that's how we solve compound inequalities.